This is section 4.4, exponential and logarithmic equations. Exponential equation is where you have a variable in the exponent. Logarithmic is where you have a log of some form. It's pretty easy to identify them. Now, our first technique we're going to take a look at is called equality of exponents. Equality of exponents says if you have b to the p power is equal to b to the q power, then you can set the exponents equal to each other. Now, b's are typically numbers, but they don't have to be. I've seen some books where they had variables there where the b is. Very simple idea. Sometimes it's not very simple to get it in the right form so you can apply this property. Take a look at number one. Got 2 to the x is equal to 16. Now the idea of this is you try to get them as both to the same number to whatever power. So we start with a larger number. We start with 16. And we're going to want to rewrite it as the other number to a power. Well, 16 is 2 to the fourth. And what the equality of exponents says is if you rewrote both of them as 2 to a power, then the 2's will cancel, and you set the exponents equal to each other. So my answer would be x equals 4. Like I say, a very simple idea, but not so simple to get it in the right form sometimes. Number 2, we got 3 to 5x minus 1 equals 9. Our first item to attempt is you always start with a larger number at first and see if you can rewrite it as the other number to a power. 9 is 3 squared. So since they're both 3 to a power now, the 3 is going to cancel. And we set the exponents equal to each other. So I got 5x minus 1 equals 2. And then you solve it. Usually it's linear. Here I'll take negative 1 over, it becomes a positive 1. Then we get 5x is equal to 3. Divide both sides by 5. And we get x is equal to 3/5. Now here we got 9 to the x plus 2 equals 27. I start with my larger number. I start with 27. And I try to rewrite it as the other number to a power. Well, 9 to the first is 9. 9 squared is 81. Doesn't appear like we can. If I try to work for the other side, start with a 9. There's really no way I can rewrite that as 27 to a power easily. So it doesn't appear to work. Some problems, you have to focus on both sides. For example, I can rewrite the 9 as 3 squared. I can rewrite 27 as 3 to the third. So you look to see if you can rewrite the numbers on both sides as the same number to a power. Now I noticed when I rewrote the 9 as 3 squared, it already had an exponent. So I put parentheses around the exponent that was there. When you put a new one up there, you have to multiply those together. Now since they're both 3 to a power, the 3 is going to cancel. And I set the exponents equal to each other. Distributive property, 2 times x is 2x, 2 times 2 is 4. Take the 4 over to the right side, becomes a negative 4, which gives us negative 1. And then divide both sides by 2. And we get negative 1/2. Now here, we have 5 to the x power is equal to 1 over the 4th root of 5. We said earlier in this chapter we never want radicals. So we want to rewrite that in fractional power form. That'd be 5 to the 1/4 power. Now once I get rid of the radical, I notice that they're really close. And both 5 to a power, except for this is trapped in the denominator. Well, we can move that up on top. We saw that before. You move anything opposite where it's at in the fraction, the sign of the exponent changes. So the 5 to the positive 1/4 becomes 5 to the negative 1/4. Now they're both 5 to a power, so by equality of exponents, the 5's will cancel. We set the exponents equal to each other. And that's our answer. Questions on these so far? Okay, number 5. We got 16 to the x minus 2 is equal to 8 to the 3x minus 1. Now I start with my large number. I'll start with 16. I'm going to try to rewrite it as 8 to a power. 8 to the first is 8. 8 squared is 64, so it doesn't feel like I can do that. Now I can rewrite 16 as 4 squared, but I cannot rewrite 8 as 4 to a power. So I go with a smaller number. I can rewrite both of them as 2 to a power. 16 is 2 to the 4th. 8 is 2 to the 3rd. Now they're both 2 to a power, so I can cancel the 2's and equate the exponents. And then solve it. 4 times x is 4x. 4 times negative 2 is negative 8. 3 times 3x is 9x. 3 times negative 1 is negative 3. Get the x's on the left side, so take 9x over, it becomes a negative 9x. Take the negative 8 over, it becomes a positive 8. Combine like terms. 4x minus 9x is negative 5x. Combine numbers. Negative 3 plus 8 is 5. Divide both sides by negative 5, the number for x. And we get x is equal to negative 1. And that's our answer. Now in this problem, if I try to use a quality of exponents, I start with 112. And the question is if I can rewrite it as 15 to a power. 15 to the first is 15. 15 squared, I think, is 225. Definitely not 112. Then I focus on both sides. And there's no way I can rewrite either side as number to a power. Um, so I can't use that method. A general method for solving exponential equations, assuming the equality of exponents fails. Step one, get the part with the variable and the exponent by itself on one side of the equals. Nothing in front of it, nothing after it. Step two, take ln, natural log of both sides. Step three, use properties of logs to get the variable out of the exponent. Step four, solve for x. Give you a couple minutes to write that down if you're writing it down. That's where it zooms on. Appeared to have crashed. Unknown error occurred. No internet. Am I muted? I hate Zoom. Internet crashed, so I had to go to the wired connection. Okay, solving exponential equations. Not sure what you heard on your end before it crashed, but solving exponential equations. Step one, get the part of the variable and exponent by itself on one side equals, nothing in front of it, nothing after it. Step two, take the ln of both sides, natural log. Step three, use properties of logs to get the variable out of the exponent. And then step four, solve for x. So let's look at this one right here. Step one, get part of the variable and exponent by itself one side of the equals. This is a part of the variable in the exponent, the 15 to the x, and it's by itself. There's nothing in front of it, there's nothing after it. We simply have 15 to a power. So that's done. Step two, take ln of both sides, natural log. So natural log of 15 to the x is equal to natural log of 112. Step three, use properties of logs to get the variable out of the exponent. We can take the x and put it out in front. So we're going to have x, natural log of 15 is equal to natural log of 112. Now, if I were to put natural log of 15 in my calculator, that just gives me a number. It's a decimal. So remember before when you had a number next to a variable and you're solving, you divide both sides by that number. It's no different here. Since natural log of 15 is just a number, we're going to divide both sides by natural log of 15. I'm going to do that. These natural log of 15s cancel, and we got x is equal to natural log of 112 over natural log of 15. Now the ln's cannot cancel there. They're not like numbers or variables, so that'd be your answer. We could plug that in the calculator and get the decimal approximation, but usually we'll want exact answers when we're working with mathematics. Let's take a look at this one. E to the 7x minus 1 minus 5 is equal to 53. Step one, get the part of the variable and the exponent by itself on one side. It's not by itself currently. We have a minus 5 after it. So I take that minus 5, move it to the right side. So I got e to the 7x minus 1 is equal to 53 plus 5. So e to the 7x minus 1 is equal to 58. Now, the part of the variable and the exponent is by itself on one side. There's nothing in front of the e to a power, there's nothing after it, just e to a power. Step two, take natural log of both sides. So we've got natural log of e to the 7x minus 1 is equal to natural log of 58. Now remember, natural log is base e. And we said before that if these two numbers match, the log and those e's are going to cancel. and this exponent will drop down. So that's property 3. Use properties logs to get the variable out of the exponent. So natural log and e always cancel each other. And that gives us 7x minus 1 is equal to natural log of 58. Now step 4, solve for x. So take the negative 1 over, becomes a positive 1. Then divide both sides by 7. And that's our answer. Okay, number 8. We got 4 to the x minus 7 equals 13. Step 1, get the part of the variable and the exponent by itself on one side. It's by itself on one side. There's nothing in front of it, and there's nothing after. We just have 4 to a power. Step 2, take natural log of both sides. Step 3, we want to use our properties of logs to get the variable out of the exponent. We have a property that says if you have log of something to a power, you can take the power and put it out in front. Now, when I put it out in front, I want to put parentheses around it because it's 2 terms. If you have 2 or more terms, you always want to put parentheses around what you put out in front. Now, to solve this is a linear equation. Looks kind of bizarre, but we have a parentheses here, and we have a number beside the parentheses. We know the distributive property is what we need to use. So I'm going to take natural log of 4 times x, which gives us x natural log of 4. Natural log of 4 times negative 7, which gives us negative 7 natural log of 4. Now, first step, get rid of parentheses. Second step, get rid of fractions. Third step, get everything with x on one side, numbers on the other side. Although this looks bizarre, negative 7 natural log of 4, that's still just a number. So I'll take that over to the right side. And then last step is to divide both sides by a number in front of your x, in this case behind the x. So we'll divide both sides by natural log of 4. And we've got x is equal to natural log of 13 plus 7 natural log of 4 over natural log of 4. We could actually use properties logs to simplify that a little bit, but there's no need for that. Once you get x by itself, then that pretty well is our answer. Let's take a look at number 9. Two to the 8x minus 1 is equal to 3 to the x minus 4. Okay, step 1, get the part with the variable and the exponent by itself on one side. Both of these have variables in the exponent. And both of them by themselves. There's nothing in front of it. There's nothing after it. We simply have 2 to the power, or on this side we have 3 to the power. So that's done. Step 2, take natural log of both sides. So we've got natural log of 2 to the 8x minus 1 is equal to natural log of 3, or try that again. Natural log of 3 to the x minus 4. Step 3, use properties laws to get the variable out of the exponent. So I take the 8x minus 1, put it out in front. Here I'll take the x minus 4 and put it out in front. Again, notice they have 2 or more terms, so you want to put parentheses around them. Step 4, solve for x. This is a linear equation. First step, give it parentheses. And here we have numbers next to parentheses. So by the distributive property, we'll multiply that through. Same thing over here. Natural log of 2 times 8x gives me 8. 8x, natural log of 2. Natural log of 2 times a negative 1 gives me a negative natural log of 2. Natural log of 3 times x gives me x, natural log of 3. Natural log of 3 times negative 4 is negative 4, natural log of 3. Very easy to multiply those together. You just put them right next to each other. Get rid of parentheses was our first step. Second step, get everything with x on one side, numbers on the other side. So I take this x, natural log of 3, move it over here. Take this negative natural log of 2, move it over here. Next step we're going to do is to factor the x out. Since we have x in 2 terms over here, we'll factor it out. And that gives 8 natural log of 2 minus natural log of 3 equals natural log of 2 minus 4 natural log of 3. Next step is we want to get x by itself. So we're going to divide both sides by this number behind it. 8 natural log of 2 minus natural log of 3 is bizarre looking, but it's still just a number. So x is going to equal to natural log of 2 minus 4 natural log of 3 over 8 natural log of 2 minus natural log of 3. And that'll be our answer. Now, next problem doesn't work with those steps. It's an oddball case. E to the 4x minus 8 e to the 2x minus 20 equals 0. If I try to get the part of the variable and exponent by itself, took the negative 8 e to the 2x, negative 20 to the right side, this would be by itself, but this part that has a variable and the exponent would not be by itself on the right side. There's no way you can accomplish that. This is actually the u substitution. I let the middle part be equal to u, first part be equal to u squared. Reason why I know that, u substitution is when you can take the middle part, excluding the coefficient, take it to the second power. When you raise one exponent to another exponent, you multiply them together. 2x times 2 is 4x. If you square the middle part and it gives you the first part, that's when you can do a u substitution. So that gives us u squared minus 8u minus 20 equals 0. This will factor using the PSD. U minus 10 times u plus 2. Zero factor property, set each factor equal to 0. So u minus 10 equal to 0, u plus 2 is equal to 0. So I get u is equal to 10, and u is equal to negative 2. Now remember the u substitution, we now want to plug our u equals back in. So whatever we said u is equal to right up here, which in our problem is e to the 2x, is what we're going to plug in down here. So I got e to the 2x equals 10, e to the 2x is equal to negative 2. Now at this point, these are exponential equations that we can solve using those techniques. Step 1, get everything with a variable and exponent by itself on one side. That's done. Step 2, take natural log both sides. So we got natural log of e to the 2x is equal to a natural log of 10. Remember, natural log and e cancel each other, so that gives us 2x is equal to natural log of 10. Divide both sides by 2, and we get natural log of 10 divided by 2. Do the same thing with the equation on the right side. Take natural log of both sides. But when I do that, I notice on the right side I'm going to have a natural log of a negative number. We can't have log of a negative number. We saw that from our domain. So x equals natural log of 10 over 2 is our only answer. Any questions on exponential equations? Now, our next type is log equations. Again, log equation is pretty easy to identify. Has a log in it. Step 1. Get everything with a log in it on one side, everything else on the other side. Step 2, use properties of logs or basic algebra to get a single log. When it's all said and done, we simply want to say log of something. Nothing from it, nothing after it. Step 3, use definition of a log to rewrite an exponential form. Step 4, solve for x. And step 5, semi-check your answer. This process works, but sometimes it gives you the wrong answers. So that's why you have to check them. Now you don't have to fully check them, you just have to semi-check them. Basically, we can't have log of 0, log of a negative number, which we mentioned before. So let's take a look at this problem. Log base 4. X minus 5 is equal to 3. Step 1, get everything with a log on one side, everything else on the other side. That's done. Step 2, use properties logs, get a single log. We have a single log. We have just simply log of something. Nothing in front of it, nothing after it. That's done. Step 3, use definition log to rewrite an exponential form. This is a b to the p equals q item. So this would be my b, this would be my p, and this would be my q. So our exponential form is b to the p equals q. So we're going to have 4 to the third is equal to x minus 5. And then our next step is to solve. So 4 to the third is 64. Take negative 5 over, becomes a positive 5. And you get x equals 69. If I plug that back up here, 69 minus 5 is 64. That's not negative, it's not 0. So that's our answer. Number 12. We have 3 natural log of 3x minus 1 is equal to 15. Step 1, get everything with a log on one side, everything else on the other side. That's done. Step 2, use properties of logs or basic algebra to get the log by itself. We could take this 3 and put as our power. But if we did that, we'd have to have 3x minus 1 third power, become kind of a nasty problem. Instead, what we can do is we can divide both sides by 3. And that would give us natural log of 3x minus 1 is equal to 5. So sometimes just basic algebra will get it by itself. Step 3, rewrite it in exponential form. So we need to identify our b, p, and q. Since this is ln, our base is e. This is q. And the right side is our p. So our exponential form is b to the p is equal to q. B was e, p was 5, and q is 3x minus 1. Take negative 1 over. We got e to the 5th plus 1 is equal to 3x. Divide both sides by 3. And we get x equal to this. Now if I plug this back in up here, plugged in for the x, the 3's would cancel out of e to the 5th plus 1 minus 1. The 1's would cancel out of e to the 5th, which is positive. That's all we care about. We just can't have log of a negative number or log of 0. Number 13. Log base 2 of x plus log base 2 of x minus 6 equals 4. Okay, step 1, get everything with log on one side, everything else on the other side. This is done. Everything with logs on the left side or numbers on the other side. Um, Next step is to use properties of logs. Log of something plus log of something. Addition becomes multiplication. That gives us log base 2. X times x is x squared. X times negative 6 is negative 6x. Next step is to use our definition of log to rewrite an exponential form. So this is our b. All of this is our q. And this is our p. Exponential form is b to the p is equal to q. So I got 2 to the 4th is equal to x squared minus 6x. And then I want to solve this. Well, 2 to the 4th is 16. Take 16 to the right side, and I got x squared minus 6x minus 16. This will factor using the PSD. If it didn't, you could use quadratic formula. I think it'll factor. Yeah. X minus 8 times x plus 2. Zero factor property, set each one of them equal to 0 and solve. X minus 8 equals 0. X plus 2 equals 0. So I get x equals 8 and x equals negative 2. But we have to semi-check those. If I take the 8 and plug it back in, I have log 8, that's fine. Plug it in here, 8 minus 6 is 2, that's fine. We just can't have log of 0, log of a negative number. Now if I plug in negative 2, right away if I plug in negative 2 for the x here, I'm going to have log of a negative number, which I can't have. So we cross that one off. And our only answer is x equals 8. Okay, number 14. Log base 3 of x minus 1 minus log base 3 of x minus 5 is equal to. Step 1, get everything with a log on one side, everything else on the other side. That's done. Step 2, use properties of logs, get a single log over here. We got log of something minus log of something. Subtraction becomes division. That's log base 3 of x minus 1 over x minus 5 is equal to. Next step is to use definition of log to rewrite an exponential form. This is our b, this is our p, and what follows that is our q. So b is 3, p is 2, and q is x minus 1 over x minus 5. And then solve this. 3 squared is 9. This is a rational equation. How you get rid of rational equations, you multiply both sides by the least common multiple of our denominators. So multiply everything by x minus 5. So then 9 times x is 9x, 9 times negative 5 is negative 45. Get everything with an x on one side, numbers on the other side. So I got 8x equals 44. Divide both sides by 8. And that gives us 11 over 2, or 5.5. Decimal isn't really an acceptable answer, but it's nice to check it with. For example, 5.5 minus 1 is 4.5. That's not negative, it's not 0. 5.5 minus 5 is 0.5. That's not 0, it's not negative. So 11 halves is our answer. Questions so far on solving log equations? Next problem is a shortcut. Now this shortcut involves equations where everything has a log on. So there's no like a number over here by itself or variable. Everything has a log. Okay, solving log equations, everything has a log on it. Step 1, use properties of logs to get a single log on both sides. Step 2, drop the log part. You can have any base, so if it's ln, it still works the same. And then solve. Then step 4, semi-check your answer. Okay, so this problem here, everything has a log on it. Step 1, use properties of log to get a single log on both sides. Here we got log of something minus log of something. Subtraction becomes division. We're going to have log of x plus 1 over 5 equals log of 4x minus 2. Step 2, after you have a single log on both sides, you drop the log part. Couldn't, no matter what the base is. So it's like the logs cancel. So we got x plus 1 over 5 is equal to 4x minus 2. And then we want to solve this. So we're going to multiply both sides by 5. So we get x plus 1 equals 5 times 4x is 20x. 5 times negative 2 is negative 10. Get everything with x on one side, numbers on the other. Gives us negative 19x equals negative 11. Divide both sides by negative 19. And we get x is equal to 11 19ths. Now if I check that, 11 19ths plus 1 is positive, so we're fine there. 4 times 11/19 is 44/19 minus 2. 44/19, I don't know what it is, but it's greater than 2. Something greater than 2 minus 2 gives us positive. So that's our answer. Again, we don't need to precisely check it, but we do need to make sure it doesn't cause log of 0, log of negative number. Okay, number 16. We have natural log x plus 2 minus natural log of x plus 4 equals natural log of x minus x plus 7 minus natural log of x plus 11. Now notice everything has a log on. That's when we can use that shortcut. First step is use properties log to the single log on both sides. We got log of something minus log of something, log of something minus log of something. Subtraction on both sides, we rewrite as division. So natural log of x plus 2 over x plus 4. So here we have natural log of x plus 7 over x plus 11. Okay, step 2, drop the log part. So drop the ln. Like x plus 2 over x plus 4 equals x plus 7 over x plus 11. Now we want to solve this. This particular one's a rational equation. So I'm going to multiply both sides by x plus 4, x plus 11. Or if you learned cross multiply in a previous class, you could do that. So when I do that, that x plus 4 cancels that x plus 4, this x plus 11 cancels that x plus 11. Now we're going to FOIL those. X times x is x squared. X times 2 is 2x. 11 times x is 11x. 11 times 2 is 22. Over here, x times x is x squared. X times 7 is 7x. 4 times x is 4x. 4 times 7 is 28. Notice they both have an x squared on both sides, so I can drop the x squareds. So that gives me 2x plus 11x is 13x plus 22. 7x plus 4x is 11x plus 28. Get all the x's on one side, numbers on the other. And we get 2x is equal to 6. Or x equals 3. I'm going to divide both sides by 2. Now we do need to check that. If I plug 3 back up here, 3 plus 2 is 5, that's okay. 3 plus 4 is 7, that's okay. 3 plus 7 is 10, that's okay. 3 plus 11 is 14, that's okay. We just got to make sure it doesn't give us log of 0 or log of negative number. Questions on solving log equations where everything has a log? Well, we'll go ahead and stop there. Um, and then next week we'll finish up for chapter 4 and keep going from there.